Today, we're diving deep into one of the most famous and, let's be honest, slightly intimidating places on Earth, Yellowstone. Now, whenever Yellowstone hits the news, it's usually with some dramatic headline about the supervolcano getting ready to blow. And while that makes for a great movie plot, the reality of what's happening beneath this stunning national park is way more fascinating and a lot less about doomsday. So, what is a supervolcano anyway? Think of a regular volcano, like Mount St. Helens. It erupts from a cone-shaped mountain. A supervolcano, or more accurately a caldera system, is different. It doesn't have a big mountain. Instead, it's a massive underground chamber of magma. Imagine a giant subterranean lake of molten rock, miles and miles wide. When a volcano this big erupts, it's so powerful that the ground above the emptied magma chamber collapses, creating a huge crater called a caldera. The one at Yellowstone is so big, it covers a large portion of the park. We're talking about 30 by 45 miles. The last time Yellowstone had one of these super eruptions was about 631,000 years ago. So, no, it's not due for another one. Volcanoes don't work on a schedule like a bus. But what makes Yellowstone so incredibly important today isn't the threat of an imminent eruption, but what it teaches us about how our planet works. Yellowstone is a living, breathing laboratory. It's one of the most geologically active places on the planet, and scientists are watching it 24/7. Why all the fuss? Because by monitoring Yellowstone, we're essentially getting a sneak peek into the inner workings of Earth's volcanic systems. It's like having a patient with a rare condition who lets doctors study them to understand the disease better for everyone else. Yellowstone is that patient for volcanologists. The things we learn here can be applied to other potentially dangerous volcanoes all around the world. So how do scientists actually keep an eye on this giant? It's like a high-tech checkup. They use a whole network of instruments. One of the key tools is a seismometer. These devices are super sensitive and can detect even the tiniest ground movements. Yellowstone experiences thousands of small earthquakes every year. Most are too small for us to feel, but the seismometers pick them all up. This isn't a sign of an impending eruption. It's the sign of a healthy, active volcanic system. The ground is constantly shifting and settling as magma, water, and gas move around deep underground. By tracking these swarms of tiny quakes, scientists can map out the plumbing system of the volcano and see where the action is. Then there's GPS. We all use GPS to find our way to a new restaurant. But in Yellowstone, high-precision GPS stations can measure ground deformation, that is, the rising and falling of the land, down to a fraction of an inch. The ground at Yellowstone literally breathes. It swells up as magma or hot fluids accumulate beneath the surface and then subsides. This gives scientists a direct measurement of the pressure changes happening miles below our feet. This breathing pattern helps them understand the magma chamber's behavior over time. They also measure gases. Volcanoes release gases like carbon dioxide and sulfur dioxide from the magma deep below. At Yellowstone, these gases escape through vents in the ground, like the famous geysers and hot springs. By sampling the air and the water, scientists can analyze the types and amounts of gases being released. A sudden change in the gas composition could, and I stress could, be a sign that new magma is rising closer to the surface. It's like checking the exhaust from a car engine to see how it's running. All this data, the quakes, the ground movement, the gas levels, is streamed in real time to the Yellowstone Volcano Observatory. This is a partnership between the U.S. Geological Survey, the University of Utah, and Yellowstone National Park. They are the ones who put all the puzzle pieces together. They analyze the patterns, look for any changes from the normal background activity, and keep us all informed. Their job is not to predict an eruption down to the day because that's impossible. Their job is to understand the volcano's current state of health and provide timely warnings if things start to change in a worrying way. So, what does this have to do with the rest of the world? Everything. The techniques and models developed at Yellowstone are a blueprint for monitoring other large caldera systems. Think about places like the Campi Flegrei in Italy, which sits right next to the city of Naples, or Lake Toba in Indonesia. These are also massive volcanic systems in populated areas. The lessons learned from Yellowstone's subtle ground swelling, or its earthquake swarms, help scientists in Italy. and Indonesia interpret what their own local volcanoes are doing. It helps them distinguish between normal, everyday volcanic restlessness and the early warning signs of a potential crisis. For example, when a swarm of earthquakes happens at another volcano, scientists can compare it to the thousands of swarms recorded at Yellowstone. Is it similar in depth? In magnitude? This comparison provides a crucial context. It helps them make a more informed judgment call about the level of risk. In essence, Yellowstone is the global reference point, the gold standard for understanding and monitoring large-scale volcanism. Studying Yellowstone also helps us prepare for the hazards of any large eruption, wherever it might happen. A super-eruption is a low-probability, high-consequence event. The biggest immediate danger wouldn't be the lava, but the volcanic ash. A massive ash cloud could spread over entire continents, disrupting air travel, agriculture, and power grids. By modeling potential eruption scenarios at Yellowstone, scientists can better understand how ash would disperse and what its impacts would be. This information is vital for governments and emergency agencies worldwide to develop better response plans. It's not about scaring people. It's about being prepared and resilient, just like we prepare for hurricanes or other natural disasters. So, the next time you see a headline about Yellowstone rumbling, remember this: it's not a monster waking up. It's a dynamic, fascinating piece of our planet that is teaching us invaluable lessons every single day. The constant monitoring isn't about waiting for the big one. It's about a global scientific effort to understand the powerful forces that shape our world. The work being done there makes everyone, from Naples to New Zealand, a little bit safer. It's a beautiful example of how studying one unique place can have benefits for all of humanity. Thanks so much for watching. I hope this gave you a new perspective on Yellowstone. If you found this interesting, please hit that like button, subscribe for more content, and let me know in the comments what other science topics you'd like to explore. See you in the next video.